Welcome to the deep dive. We cut through the noise, get straight to the insights that matter. And today, we're plunging into something that, well, it affects all of us, really. Road safety. Just think about this for a second. In India back in 2017, the numbers were staggering. Around 1,374 accidents and 400 deaths every single day.
Wow.
Yeah, that breaks down to 57 accidents, 17 lives lost every hour. And, the really concerning part, those numbers were actually going up year over year.
It's a really sobering picture, isn't it? And something that often gets missed, I think, is that our usual solutions, the conventional barriers on highways.
The concrete walls, the steel rails.
Exactly. They're meant to absorb impact, sure, but they often lead to really severe consequences for the vehicles and for the people
Right.
inside.
Massive damage.
Massive damage, yeah. Cars can sometimes even catapult, or fuel tanks can rupture.
Well,
Sometimes these fixes end up causing more problems. Traffic jams, things like that. Kind of defeats the purpose.
that's a really critical point.
Mm-hmm.
So if the old way is basically hitting a rigid wall designed just to stop you dead,
Mm-hmm.
what if you rethought that completely?
Yeah.
Like a different philosophy for the barrier itself.
Yeah.
One that doesn't just stop you, but, I don't know, works with a collision course somehow.
Mm-hmm.
So our deep dives today, it's all about exactly that. An innovative, maybe even revolutionary approach. It's called the rolling barrier. Came out of a small Korean manufacturing company initially.
Right.
And our mission, really, is to unpack how this thing that looks kind of simple on the surface, how it radically changes how we think about road safety. It offers genuine protection, and it's often surprising how it works.
Mhm.
Okay, so let's start with the basics. What does this thing even look like? Because you said it's definitely not your usual concrete slab or guardrail.
No, not at all. It's very distinct visually. Imagine continuous pipes, right?
Yeah.
And they're covered with these bright, often colorful urethane rings, almost like giant beads strung on a vertical frame.
Uh-huh.
The source material actually had a great description. It called it an erected abacus.
Huh. Okay, I can picture that. The
Oh.
vertical abacus on the roadside.
Exactly. It captures that unique, segmented look perfectly. But the real genius, it's not just how it looks, it's the core principle behind it.
Right, the visual is clear. Erected abacus, got it.
Mm.
But how does that clever principle actually work? What's the fundamental difference when a car, hits it?
Okay, so this is the game changer. Instead of just absorbing the impact energy like a wall does, the rolling barrier converts it
Converts it into what?
into rotational energy. Just think about that. When a vehicle hits it, those rollers, those beads, they actually spin with the impact.
Ah, okay.
And this conversion, it doesn't just lessen the initial shock, it actually helps propel the vehicle forward a bit rather than that sudden violent stop.
So it guides it, almost.
Yes, yeah, assists it in staying on its track. And critically, it helps prevent overturning, which is
Yeah.
a huge risk with conventional barriers.
That really is a different way of thinking about it.
Mhm.
Less of a destructive stop, more of a controlled redirection, a guided redirection. But okay, if it's redirecting and spinning, does that need totally new space-age materials? Or is it more about using existing stuff in a smarter way?
It's definitely about smarter materials. The
Oh.
barrels themselves, they're made of a special chemical compound, basically a hard rubber, specifically ethylene vinyl acetate, EVA.
EVA, heard of it in like running shoes.
Yeah, similar stuff, but engineered differently here. What's really clever about EVA in this context is its excellent shock absorption. It's got better flexibility, better elasticity than other resins, and it's surprisingly light. Lighter than rubber, but actually more elastic than, say, urethane. Plus, big bonus, it's eco-friendly and really resistant to damage. That helps with longevity, maintenance costs.
Okay, so not just any plastic. It's a specific engineered compound chosen for those properties. Elasticity, shock absorption. But the cleverness doesn't stop with just the material, right? The design itself. Are there other features, maybe less obvious ones, that make this system work so well, both for safety and practicality?
Oh, absolutely. The design is full of smart touches. For instance, those barrels, they're separated and recyclable, which makes maintenance way easier. If one gets damaged, you just replace that one section, not the whole thing.
That makes sense. Cost effective.
Exactly. And then you've got these stopper boards. On the top and bottom of the barrels, they're designed specifically to guide things like debris or even parts of the vehicle back onto the road, preventing them from flying off.
Ah, okay. Containment.
Right. Plus, the height is adjustable, so it can handle impacts from regular passenger cars all the way up to heavy lorries. And visibility, they've thought about that too.
Oh.
Well, noticeable colors, obviously, but also self-luminescence and even solar-powered LED guide lamps integrated into it for nighttime.
Solar-powered LEDs. Wow, okay. That's really thinking long-term. sustainability built right in.
Mm.
But beyond just being seen, what about preventing something really dangerous, like a car actually going over the barrier? I think I saw something about an overhang effect.
Yes, the overhang effect. It's a clever bit of the physical design. It literally helps prevent vehicles from climbing up and over the barrier during an impact, keeps them on the ground.
Crucial.
Very. And the actual surfaces that take the first hit, their pneumatic low-pressure rubber tubes, softens that initial blow even more. And then there's the underlying structure. Props installed at precise 0.7-meter intervals. These give the barrier immense bearing power, real strength.
Uh-huh.
And again, because these props are independent, if one section gets damaged, you only replace those damaged parts. Keeps those maintenance costs down low.
So it's not just the spinning barrels doing everything. There's this whole robust kind of hidden support system underneath. Sounds like multiple layers working together.
Exactly right. They call them 3D buffering frames and dense props. They support the rotating barrels. And the frames, the upper and lower ones, they actually adjust slightly to different tire sizes.
Why is that important?
It helps prevent the vehicle's steering system from losing function during the impact, keeps the driver with some potential control. It's genuinely a multi-stage shock absorption system.
Go break that down. Multi-stage.
Right. So stage one, the roller absorbs the main collision shock, converts it to that rotational energy we talked about. Stage two, a front rail absorbs the second shock. Stage three, a back rail absorbs a third shock. And the whole thing is reinforced. There's a metal pipe inserted into the posts holding it all up. It's all about distributing and dissipating that energy effectively, piece by piece, not all at once.
This really does feel like a paradigm shift in how you design a barrier. Let's compare it directly then. How does this rolling barrier fundamentally stack up against what we usually see? The concrete, the steel guardrails we mentioned earlier.
Well, the key difference, as we touched on, is that conventional barriers, concrete or steel, they work mostly by rigid absorption. They're designed to just stop momentum. Dead.
Right. Brute force.
Brute force, exactly. But the source material we looked at, it calls this prevailing customary system substandard, sometimes in preventing the worst outcomes.
Substandard, huh?
Yeah, because that rigid stop can lead to severe vehicle damage, the potential for catapulting, even, like we said, exploding fuel tanks. It achieves safety, but often at a very high cost to the vehicle and potentially the occupants.
Okay, what about other types then? We sometimes see, chain link fences along roadsides or maybe temporary things like sand barrels. Are they any better?
Not really, no. Chain
Right.
link fences, they often cause significant twisting, tearing damage to the vehicle itself. Plus, they're expensive to fix afterwards.
Right.
And those temporary things, empty barrels, sand containers, water containers, they tend to be pretty destructive to the car hitting them. And crucially, they don't really pocket or stop the vehicle in a controlled way. It's still a fairly violent impact.
So even things designed to give way a bit are still problematic.
Yeah, even breakaway posts, for signs or lights, they're an improvement, sure, but they still usually mean costly vehicle repairs. And you have to reinstall the whole pole. Whereas these rolling barriers, sometimes they can even reuse existing posts if they're suitable. Saves cost and time.
Okay, so they're not just softer, they're fundamentally interacting with the vehicle in a smarter way. Now, engineers often talk about barriers in terms of stiffness, right? Flexible, semi-rigid, rigid. Where do rolling barriers fit on that spectrum?
That's actually one of the most interesting technical points. Traditional barriers usually fall neatly into one category. Flexible, like cable barriers that deflect a lot. Semi-rigid, like standard guardrails that deflect less. Or rigid, like concrete, which barely deflects at all.
Uh-huh.
The rolling barrier is unique because it kind of possesses both flexible and semi-rigid properties at the same time. It offers this dynamic response that doesn't fit neatly into just one box.
Dynamic response, meaning
Meaning it gives way and redirects simultaneously. It's not just giving way like a cable, and it's not just resisting like concrete. It's doing both, adapting to the impact. That dynamic quality is really key to how effective it is.
okay, theory sounds great, design sounds clever, materials sound smart, but the proof, as they say, is in the pudding. What about crash tests? How do these things actually perform under rigorous testing? And maybe more importantly, what's the real-world impact? Do the numbers back it all up?
The crash test results are genuinely compelling, quite impressive actually. For example, they've been tested to the SB5 crash test level, which is a pretty high standard.
And the results?
Well, take a key safety metric, theoretical head impact velocity, THIV. It measures potential head injury. The limit is 33 kilometers per hour. The rolling barrier test showed 32.4, so well within the safe limit.
Okay.
Another one, post-impact head deceleration, THD, limit is 20 Gs. The test showed 9.9 Gs. Again, far below the danger threshold.
So much gentler on the occupants.
Much gentler. And critically, during these tests, there was no scattering of barrier parts, nothing flying off to cause secondary hazards. And the test vehicles, they weren't overthrown, they weren't stopped suddenly and violently. It points to significantly enhanced occupant safety.
That is fantastic for the people inside the car. What about the barrier itself? Does it hold up? And how does it handle different types of vehicles? You mentioned it's adjustable, but does it work equally well for a small car versus, say, a big truck?
It adapts remarkably well. So with a small car, they tested a 900-kilogram vehicle hitting at a 20-degree angle. The barrier successfully redirected it, got it back onto the normal moving track, protected the occupants, prevented secondary accidents.
Okay, small car, check. What about something heavy? A truck? A bus?
Yeah. So with much larger vehicles like a 10-ton truck or even a 13-ton bus hitting sideways, that rotational friction mechanism we talked about, it did a great job minimizing the momentary shock. There's specific data from one truck test. It hit at nearly 90 kilometers per hour, 89.8 kph at a 15-degree angle.
Okay, that's a serious impact.
It is. And the result? Only 0.215 meters of dynamic deflection, so the barrier barely moves sideways. The estimated exit speed was incredibly low, just 8 kilometers per hour, with a 0-degree exit angle, meaning it went straight along the barrier line, and the damage to the barrier itself described as mild.
Mild damage from a 10-ton truck at almost 90 kph. That is remarkable.
It really is. Shows the energy conversion is working incredibly well.
What about a typical passenger car test? Like something common like a Dodge Ram pickup?
Yep, they tested those too. Under MSH compliance, which are rigorous U.S. standards, a Dodge Ram impacted at over 98 kilometers per hour at a steeper 25-degree angle. The estimated exit speed was about 48 kph at a 21-degree angle. And importantly, the vehicle stability was rated as good. So even with a common, fairly heavy passenger vehicle at high speed and angle, it performed very well. They test with things like the Kia Rio too, ensuring it works across vehicle types.
Rigorous testing is key. But here's the million-dollar question for me. Does it actually work out there, on real roads? Do these great test results translate into fewer accidents, fewer injuries in the real world?
Absolutely. And we have concrete examples. Take Busan in South Korea. They installed these rolling barriers on 2 specific road sections. They were downgraded, curved sections, basically, known accident hotspots.
Okay, prime candidates.
Exactly. And after installing the rolling barriers, the number of accidents in those specific areas dropped by more than 50% in just 1 year.
50?
More than 50%. That's not just a small improvement. That's a massive, direct, measurable impact on safety, preventing dozens of accidents, potentially saving lives in just those 2 spots.
That is genuinely astonishing, a 50% reduction. It almost sounds, well, too good to be true. Are there any, specific situations where maybe they don't work as well? Extreme weather?
Yeah.
Or maybe really tight spaces where redirecting isn't even possible?
That's a fair question to ask. I mean, they're designed for versatility and durability, including handling different weather conditions. But their real strength, where they shine the brightest, is exactly in those situations where a traditional rigid barrier would cause that high-impact, abrupt stop. So think curves, ramps, medians, places where vehicles are more likely to lose control and hit the barrier at an angle.
Right.
The redirection mechanism does need a little bit of space to work best, some runoff room. So while they're adaptable, you get the maximum benefit in areas where a vehicle can be safely guided back onto its path, or at least along the barrier line, rather than just being instantly halted in a very confined space.
Okay, that makes perfect sense. Match the solution to the specific problem area.
Yeah.
So considering all this, the design, the tests, the real-world results, where do we go from here? Where are these rolling barriers most effectively deployed? What's their ultimate role shaping the future of road safety?
Well, their versatility makes them ideal for a lot of those notoriously dangerous spots we just mentioned. Sharp curves, the source even suggested replacing existing metal median barriers on places like India's infamous highway to hell as a potential application.
Wow, yeah. High-risk zones.
Exactly. Also ramps, on-ramps, off-ramps on all types of highways, medians between opposing traffic lanes, even think about parking garages, those tight entrance and exit ramps where impacts can happen easily.
Okay, so targeted application where angled impacts are likely.
Precisely. It just seems clear, putting it all together, that the rolling barrier system really does prove superior in many scenarios compared to older barrier types. In stiffness, strength, and certainly in crash test performance when it comes to occupant safety and vehicle redirection.
So wrapping this all up then, what's the final takeaway message about this technology that's placed in the future?
I think the ultimate message is that this system is specifically designed to save lives and prevent the maximum amount of vehicle damage. It really powerfully reinforces that idea that, well, life is more precious than vehicles.
Hmm.
It's not just a small tweak or an incremental improvement on old ideas. It feels like a genuine leap forward. The source calls it future technology in transportation engineering, and based on the evidence, that feels pretty accurate.
That is a powerful and honestly quite hopeful note to end on. The core idea, changing from rigid absorption to dynamic energy conversion, is genuinely fascinating for something as, well, seemingly basic as a road barrier. Rethinking passive protection with an active, intelligent solution. So what does this mean for you, listening in? Well, if converting impact energy into rotational energy can make such a difference on our highways, it makes you wonder, doesn't it? What other areas of our lives rely on passive, rigid protection right now? Could they be transformed by rethinking dynamic problems? Maybe finding active, energy-converting solutions instead? Sports safety gear, personal protective equipment, maybe even how we build things. Just something to think about. Until next time on The Deep Dive.